Hi, hello everyone. So last time we left off with our index buffer, and this time what I want to cover is I kind of wanted to do texturing, but then I realized that we have to cover bind groups and how and way of pasting our global data to our shaders. So we're going to start with that. We're going to learn how to paste global data to shaders first, and then next time we're maybe going to deal with texturing. Uh, with that said, it's kind of not so simple, but at the same time, it's not so hard because we kind of have to define our layout and how it looks in memory. And in WebGPU, we do that with bind groups and bind group layouts. So we're going to explain that. But first of all, we can just go to our shader and then we can uh, define something. And what I want to define is model matrix, and we're going to cover model matrix in the future. But for now, we're just going to use it to scale stuff around. Model matrix, if you don't know, it's kind of used for scaling, translating, or rotating your points, and therefore your shape. In our case, it's quad. But this time I just want to focus on scaling, but we're going to define matrix regardless. So let's get started with it. So for start, in our shader, we just want to have a uniform variable, and we're going to explain uniform, but uniforms are global variables. Similar concept is there. OpenGL has similar concept called uniforms, and it's global data that's placed in shader. What does that mean? Well, if you remember last time, we had data per vertex, right? For each of the edges of the triangle, we were passing data, and that was this here position, right? Usually we had 4 positions for top left, bottom left, right top, and then bottom right corners. But this time we just want some global data, and that's going to be our transform, and it's of type matrix 4x4 float. So I'm just going to zoom in so that you can see. So this is what I have added. And how do we describe it? Well, we describe it with groups and bindings, and we're going to comment that a bit later. But let's just define binding 0 here as well. And then what we want to do with this transform is we just multiply transform and then times our position. Okay. So going forward, this is our topic for today, our global data. And here we already mentioned uniform. It's just global shader variable. And we just create some WebGPU buffer with type uniform. So that's how we're going to paste the data in. So we can start with that, and then we're going to go to the slides as we go. So for our uniform, it's going to be yet another buffer similar to index or to vertex buffer. So I'm just going to be lazy and copy paste our vertex buffer and create a new one. And here I'm just going to call this uniform buffer. And then paste it here, rename to uniform. Here as well. This is all right. So I just want to copy in our vertex buffer. I had this alias because the buffer is used name in C#. So I can do this, clean it up a bit. So we have that. Let me just see my notes. What have I planned? So the size property we're going to need, but vertex count property we don't need. Size is important, vertex count is not. For the data, it's actually going to be generic. So we can say t, and we can say where t is unmanaged. Unmanaged. Right, actually it needs to go behind by disposable. Or where does it need to go? Oh my. I forgot how to write generics. Oh yeah, it is unmanaged and then it's disposable. Exactly. So this is a bit embarrassing, but it happens. But then I mentioned we're not going to have vertex count, and here it can just be size of t actually, right? And here we're going to take the t in. So our t, here we're going to have a new function. It's going to be called create uniform buffer. And we can probably create it already. But let me see. So we're going to also have another method because we're going to have to update it quite often, right? Because we want to animate that quad. Or maybe we're going to want to create animation, and usually the global data you need to update it quite often. So we can do that. And here we're also going to create a method to do write to buffer. But let's go first with this create uniform buffer. And I'm just going to copy paste it. We already had our buffer util, and similar to this create vertex buffer, copying once again, we're going to have another method, and I'm just going to call this create uniform buffer, and it can take some data t, right? T, and we're just going to say where t is unmanaged. All right. Here it's size of t. We don't care about this. Application type is uniform, and then here we can just probably pass the in. I guess we don't need this pointer because t is already unmanaged type, so we could just say data here, and it works. And we're also just going to have another small method which is going to be called write uniform buffer, but it could also be called write buffer. It's not relevant. And usually we're passing engine. Sorry. Then what we were passing is we're going to need buffer here. So let's do buffer pointer buffer, and then t of data. So another one generic. It needs to be unmanaged. T, right? Typo. Lots of typos, and actually I just need this one. And then we can here say int size of t. Right? I think that will work. And in our uniform buffer, we can just say now here we need WebGPU util buffer, write uniform buffer. We need engine, that buffer that we have created, and then the size as well. Not the size, what am I doing? We need the data, right? Data, all right, now it's correct. So further, what I want to do is just go to our program, and here I'm just going to write what we want to do before, but then we're going to have some additional steps, right? So for our matrix, I just want to create, so we're not going to need uniform buffer here. Let me see. Actually, not yet. First of all, we're going to go to our unlit render pipeline, and here we can create something called transform, or not transform, actually matrix, right? It's just 4x4 of float, and I'm going to call it transform. Here we're going to have that matrix. Transform, and we can just set it to identity. Right? But we're also going to need to write it somewhere, right? And how do we paste it to our shader? Well, we created that uniform buffer, and we paste it with uniform buffer to our shader. Right here, right? So in our unlit render pipeline, we're going to need, and I'm just going to say here transform, we're going to need that buffer as well. So uniform buffer, and what is our t, right? Because we want to paste that matrix in. So our matrix of type float is going in, and I'm just going to call this one transform buffer. That's good. So we're going to need to initialize it. It's complaining about something. The system I disposable. So here is unmanaged. and then okay, all right, now it's good. So still embarrassing for me, but we're good. So in our only trained pipeline, so here I'm just going to return the transform, and here what I want to do is of course set that transform to value, but whenever we change transform we can also update that transform buffer, right? With what do we update it? Well, with that transform matrix, right? So whenever we set this transform from the outside, we also update the buffer so that the GPU can so basically that we pass our data to the GPU and therefore shade. Okay, we need to create that transform buffer, and here I'm just going to have a small method which is going to be private void create resources. So whenever we want to create resources, we're going to do it in this method. It's just going to be cleaner that way. So our transform buffer is new uniform buffer. It's complaining about something. Parameters. So we need the tangent parameter, and that's it. So we can then initialize it. With what do we initialize it? With data. And here I forgot to remove, of course, vertex count. We don't use it. We don't care about it. So we're good here. So back to our only trained pipeline. Of course, we're not passing data in, we're passing the transform in. And just at the end, what I want to do is just dispose of it. All right, I think we're good now. So back to here. So now we can create the transform in our program. And what I want to do is following. So here we're going to have one small value for scale. We're going to have scale direction, which is going to be positive by default, and this can be integer. Then what I want to do is just kind of animate that scale. So here I'm going to say if scale is greater than 2, we want to change direction to -1, else if scale is less than 0.5, it can be whichever number you want. We're just going to set scale direction to this, and then we can say our scale plus equals some small value, right? Because this is going to be very fast, then times scale direction. And here we can say now only train the pipeline transform is matrix 4 by 4 dot create scale. So we can already create a scale matrix, and here we can paste scale and then 1f. We don't want to do anything with z component, so we just want to scale x and y. And if I do this, it's complaining about something. Oh, what's wrong with this transform dot scale? Create scale, this is weird. The non-generic, I mistyped. So you need to use it from the silk. So just make sure that x here is big if you get this error, because the other matrix is from the another namespace, which we don't use. Good. So with that said, if I run it, it will fail. Right? It kinda crashed here. Object reference not set to instance of object. Because we never called this create resources. So let's do it right here. But if I run it, it still fails, and now the error is, let's see an error here. So one of the things is I mistyped something in shader, so let's fix that first. So that's probably just on my part, maybe it's not yours, but let's try again. So let's see error now. Okay, associated with the pipeline layout associated with the current rendered pipeline contains a bright group layout with index visual, which is incompatible with blah 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 blah. So we get errors related to this basically groups and bindings. And why does it happen? Well, first of all, we haven't defined layout, and if you check our unlit rendered pipeline here, we're going to have another descriptor element which is called layout, and we need to fill that in. So whenever we have something like this, uniforms, right, or storage locations as well, but generally uniforms, we need to define layout to our pipeline. So for layout, we can just say here, we're going to have another parameter, and I have it already here. So because I think, did we leave it last time? I don't remember, but just make sure to add this as a third parameter after the shader module. We're going to have pipeline layout. And let me see, have I pasted it somewhere? Did I use it at all? Layout. I did. It's right here. So whenever we create descriptor, we just want to paste pipeline layout as well. So you can just add here descriptor layout if you're missing this. And with that said, we kind of have to create that layout, which is just description of this, right? And in the future, right now we have group 0 and then binding 0, but it can be binding 1, and then this might be, say, let's say view matrix, right, or whatever. But it can also be different binding group, right? It could be binding 0 but binding group 1, right? So, and I'm going to explain it now how it works. So let's go back to our slides. So what are these bind groups and bind group layouts? So it's used to pass uniform buffer, right? In our case, it might be some other stuff as well. It will be textures in the future or samplers, stuff like that. It's just an interface, right? This whole group, right? WebGPU bind group is interface that defines some set of resources to be bound together in a group and then passed to GPU and to pipeline, right? It will describe how resources are used in shader stages. So we can say, okay, use this in vertex stage, use this in fragment stage. It will also, by binding resources, it might be a view matrix. In our case, it's model matrix, but it might also be perspective matrix, but it might also be a texture sampler, stuff like that. In shader, we just use this add group and bindings attributes to layout a bind group. To layout means just basically to say how which class or how many memory it will use. It's just kind of laying out memory, so to say. So it's going to be used something like this, and this should be bind group 2, but it doesn't matter. So we're going to have a couple of bind groups, and then in bind groups can have bindings, right? And here we have some bindings, and then here we have some bindings as well. And let's say that our bind group 1 is camera perspective matrix and camera view matrix, and then bind group 1 contains model matrix and then some variable texture tiling. We're going to cover that in the future, but why is it this separate? For example, when we set up a camera, so you just need to update camera once for all of the entities that you create. So camera will just have one bind group, and we can paste that bind group everywhere, right? To our model shader, to our, in future it will be maybe skybox, it might be terrain, it might be some enemy. So all of them can just reuse the bind group created by camera. But bind group 1 is different group because it's related to model, right? It makes sense. Terrain, it will have its own model matrix, but enemy might have its own model matrix, right? And then there can be multiple of enemies, which all of them will have their own model matrix, and maybe some texture tiling property. And then in fragment shader, we usually pass something related to material. So in our case, it will texture via texture sampler because we want to texture our model, right? And it might be diffuse color because we want to color our model to some of the colors. And then, so this is just bind group, right? But when you create a bind group, you kind of have to create a bind group layout. Yeah. Basically it just creates there is bind group, which we bind and then paste to pipeline, but there is also layout, which kind of says where in the shade these things are. Yeah, that's it. So let's go to code, and then it will become clear. So now in our pipeline, we're going to have a lot of work. But first, let me check pipeline here. So I want to create this bind group layouts. So what we're going to need, and I'm looking at my notes here because this is not so easy and obvious. We're going to have bind group layout related to our transform. In future, we might rename it to model layout or something. But let's leave it for now. So we're going to need layout, and let's just set here layout describes layout or memory spaces or whatever. And then we need bind group actual data, right? So this is essentially bind group will be actual data that we paste in, but transform bind group layout is just description of the data, so to say. So maybe a description of our layout and description of data. So we can describe it as that as well. That's good. So first of all, we're going to work with layouts. So here I started. So I'm just going to say create bind group layouts, and it needs to be void. So we have this transform bind group layout, and as usual it will be engine WebGPU, and then we can call device create bind group layout, right? And here we need to pass our usual device, and as usual we have descriptor. So for our descriptor, bind group layout descriptor. So our descriptor has properties entries. So just to explain it once more. So this bind group, we're going to have one bind group, right? But we can have multiple bind groups, and bind group refers to this one here. When we pass second bind group, we're going to have group 1, and when we pass third one, we're going to have bind group 2, right? But binding is actually binding of bind group. Right now we're going to have one. So right now, where are you? Here. So this one takes entries, and the entries are actually referring to bindings. So let's check these entries. So it has this description bind group layout entry. So let's try to create it. So we can say bind group layout entry. So it's going to be an array, pointer array. So I can just use stack allocate, and we can just say 1. So it's just an array, stack allocate array, right? And then we need to describe that first one. So I'm just going to say 0 here. And then we can set it to new bind group layout entry. Then 0 again. So binding, right, is 0. Why it is 0? Because it's 0 here as well, this binding, right? So it needs to be 0 here as well. So if we had the second binding at position 1, we would pass 1 here, but we do not. And then back here. So visibility, it's just in which shader stage is it visible. It's in vertex for now. In future we might cover fragment, right? Because this is vertex function and we use it in vertex stage. Okay, and finally we have buffer, and this is just kind of description, and here it has a couple of properties. So it's an object, right? We create a new buffer binding layout, and here we can say type. So what is our type? Well, you can see we have multiple types, but our is uniform, right? And that's good because, right, here we use uniform, right? Okay, let's paste those entries in. Bind group layout entries, descriptor, entries count. For now it's 1. We have created a descriptor and then we just paste the descriptor. We have created transform binding group layout. So maybe we can paste it to a pipeline now. Let's see. Here we have pipeline. So we can create that layout. We need to call first this, right? Then shade the module can remain here. I just want to have it something for visibility. So I'm going to say shade the module, layouts, and then here, so layout. So we can say pipeline layout, right? And that's our third parameter. If we check here, it's pipeline layout. So I'm just going to call it like that as well. Pipeline layout is, as usual, engine, WebGPU, device create pipeline layout. So as usual, we need to pass in the device, which is on our engine, and that pipeline layout descriptor as well. So we can say pipeline descriptor. All right. Oh, what's happening? In. This needs to be, oh my bad, this needs to be pointer. All right, we don't need this in. Maybe I can zoom out a bit. Yeah, this is probably better, it's a bit more readable. Okay, so as usual, we need to paste those bind groups in, and how we do that. So if we check our pipeline layout descriptor, so we have bind group layouts and it's pointer, as you can see here. So we're going to need to create a pointer array, and then we can paste it. So bind group layouts, and depending on this array here, right? Depending on indexing array, right? It will define also these groups. So first entry will always be group 0, second entry group 1, etc. So let's just create that as well. So we're going to need that. We can say here bind group layout. It's going to be pointer bind group layouts. It's an array. Then we stack allocate once again. Bind group layout. But now we allocate pointer, and for now we just have 1, right? And that's going to correspond this to group 0. So pipeline layout descriptor, not yet. Bind group layouts 0 is which one? Transform bind group layout, right? And here that's it actually. We can just paste it in. So bind group layouts is bind group layouts, and then we just need to set count as usual, right? Some other properties, label is not relevant. Maybe in future we're going to cover it when we mention debugging. But for right now, I think that's enough. We have pasted to a pipeline, and if we try to run it, we're still going to get an error, but we're getting there. So let's try it. So let's see error. Still error. All right, we just haven't pasted our data in yet. So let's actually create that bind group, and then this error will be probably gone. Okay, for bind group, so we created layout. We described our layouting, and it now only trained the pipeline now. So we need to create this transform bind group. And to create that, we're going to have another method. Void create bind group or groups for now. In the future, we might refactor it a bit. But here, so we can say transform by group is equal to, as usual, we have engine, WebGPU, device, create bind group. So engine device, and as usual, we have descriptor, so we can say bind group descriptor. Let's create that descriptor. What do we have? We need to paste that layout in of this bind group, which was transform bind group layout. Then, as usual, we're going to have entries, right? So the first entry, and now this is where we paste data in. So let's just create those entries, and if we look at type, it's bind group entry. So you're probably already used to it. So we're going to have bind group entry. It's a pointer, and then we have some bind group entries, stack allocate, right? One entry for now. In future it might be more, and then new. So let's check the properties here. So I'm just going to paste so that I have to type. So here for entries, you can see buffer, sample, texture, view, and those are data types. So we have our buffer now, buffer, and what do we paste to buffer? Well, we paste that buffer that we have created, right? If you remember, transform buffer. So this is our actual data. This buffer to which we paste our matrix. So that's our actual data. Then other properties that we wanna have is just size. We need to define size, and we also had this transform buffer size, which is just size of that matrix. And also we have binding, which I forgot, and that was just 0, and that's good. So for entries, we can just paste this bind group entries. As usual, we're just going to set entry count to 1, and that's it. We can paste our descriptor, and we can call create bind groups, and that probably makes sense after the resources, right? Because our buffer needs to be created. So resources, bind groups for resources. All right, we have that bind group. So now we just need to paste it in somewhere in our shader, and I'm going to do that somewhere right here. WebGPU. So render pass encoder set bind group. That's the method. So we need to paste this thing in, right? Current pass encoder. Group index is 0, right? Because it's also 0 here. All right. Then what else? We need to paste transform bind group in, and then we don't have any offsets. And if I run it now, maybe it will work. And it does work. Perfect. Perfect. That was kind of hard, but we're there. So just to recap real quickly. So when we want to pass some data in, let's say our uniform, we need to define group to which it belongs to and the binding which it belongs to. So usually if you're used to OpenGL, you could have defined bindings, right? Something like uniform, and then you have get uniform location or whatever. Here with WebGPU, the new concept is groups, right? Usually you just had bindings in most of the other APIs, but here we have groups as well. So we kind of have to group those bindings. Then what we did is we just created some uniform buffer, right? Type was, if we remember correctly, it was here actually. We had this uniform type of it, and then we just written that matrix into our uniform buffer, right? And we do that every frame because here in program, whenever we render, right, we set this new matrix, which was there. Look at here. We had this update, and we were updating the transform buffer. But before we could even use that, we needed to create these layouts. And what does layout say? So we had this one, transform bind group layout. It basically says how it will be layouted in memory, right? It describes the data. It essentially just describes data, these groups, these bindings. Then we just needed to paste it to pipeline, and with that layout we could create finally bind group, and bind group actually contains our data, in this case our buffer, and then we just needed to bind it once more in our render pass so that it's actually passed in. So that's kind of how it works. Try to get used to it, try to play with it, maybe try to understand it, because it's kind of complex, but once you get it, you will really understand it. It's not that hard. In the future we will pass more data in, and then it's really going to become clear. So that's it for this video. Next time we might do actually camera as well, because then this binding and layouts, these things will really sink in. So yeah, if you enjoyed this video, like, subscribe, and until next time.